So this is the idea using this notation here that dy dx, our derivative, is dy du by du dx, where you can make a function u inside of another function f. So u is our function inside. So when we look at this first example, our function inside is 3x plus 6. So what we do is we temporarily make u equal to that, and then we substitute that in, and then instead of having y equals 3x plus 6 to the 5, we just have y equals u to the 5. Using the chain rule definition, that if you make this substitution, if you have a function inside of another function, then the derivative, dy dx, is the same as the derivative with respect to u times by the derivative of u with respect to x. So what does that mean? Well, dy du, since we have our function y equals u to the 5, if you were doing the derivative of that, that would be easy. The 5 would come out in front, you would subtract 1 from the exponent, and that would just be our regular power rule. And since u is equal to 3x plus 6, if you wanted to find the derivative of this function, du dx, well, that's an easy one to do as well. It's just equal to 3. So again, let's think about what these notations mean. dy du says find a function y that's in terms of u, which we have here, y equals u to the 5, and do the derivative. Straightforward. Du dx says find a function u that's in terms of x, which we have right here, do the derivative. Then dy dx, the derivative of the original function in terms of x, will equal dy du, which we figured out to be 5u to the 4, multiplied by du dx, which we figured out to be 3. Then to solve it completely, to write everything in terms of x, u was equal to 3x plus 6. So if we substitute back, we'd have this, and if you multiplied the 5 and the 3 together, you'd get 15. But this is all we have to do. So you can always do this as a longer process. However, we're going to just visualize and see right away that the 5 is our outside function. And we can bring that 5 out in front and take away 1 from the exponent, leave our function the way that it was inside, and then multiply by the derivative. And that's how we're going to process a lot of these ones moving forward. So here we have a question. We could do this in one of two ways. We could use the quotient rule with the chain rule, but this one will be simpler, and you'll notice that sometimes you're going to want to use your negative exponent rules to change things into a different form. And when I do the negative exponent rule here, now I've got a power rule. Inside my power rule, I have a function that you could take the derivative as well. So we recognize that this is a chain rule. Chain rule says do the derivative of our outside function. A negative 4 would come out in front. Negative 12. Inside stays the same. Subtract 1 from the exponent. Then multiply by the derivative of that inside function, which will give you 2x plus 1. So just like we did before with radicals, we'll take the time to first change this to an exponent. A fifth root is the same as the power 1/5. And now we'll apply the chain rule. So I'll give you a little head start, and I'll put up the answer in a second. The 1/5 would come out in front. The inside function would stay the same. Subtract 1 from the exponent and multiply by the derivative of the inside 6x plus 7. So first of all, we could change that square root to an exponent by making it a half. And then we could bring that whole expression to the top of our fraction by making it a negative 1/2. And if you can go directly from here to here right away, that's great. So using our negative exponent rules and our rational exponents, we can change it to this. Now we have a chain rule. We have a function inside of another function. If we look from our outside, we have the power rule first. That negative 1/2 will come out in front. Keep the inside the same. Subtract 1 from the exponent. Then multiply by the derivative of the inside. And we have our answer. Now, since we've just done the chain rule, working backwards on this one is easy. But later on, when we get into our integration unit, we're going to have to work backwards, and it's going to be a little bit tougher to see this. But can you see that this expression at the end that's multiplied by afterwards is the derivative of this inside function here? So if we were working backwards, we would have had this inside function. We would add 1 to the exponent. That accounts for the 5 being in front, right? So we don't have to worry about anything in front. And we don't have to worry about the 6x plus 5 because that would have been part of the chain rule. Of course, you could add your favorite number here. Today my favorite number is 3. Or 7, or anything at the end because the derivative of a constant is 0. So sometimes when we say we can add any number, sometimes we write plus c. Although this question said find a function with y, function y with this derivative, so you wouldn't need to write the plus c or plus anything else there. This would be enough to show a function that has that derivative. Whenever you're working backwards, once you've done that, you can do a quick check. If I did the derivative of this, it would be the chain rule. The 5 would come out in front. The inside would stay the same. Subtract 1 from the exponent multiplied by the derivative of the inside. And sure enough, it matches up.